All right, so problem one, we have that many professional schools require applicants to take a standardized test. It says that, let's suppose that 1,000 students take such a test, and then several weeks after the test, Pete receives a score report. Got a 63, which placed him at the 73rd percentile. This means that, well, before we decide whether it's A, B, C, or D, or E, let's make sure it's clear what percentile means. So percentile is a number or a value that tells you what percent of the group that you know that you're a part of, what percent of them that you did better than. So if you're in your 73rd percentile, that means you did better than 73% of them. Meaning that your score is above 73% of them. It really has nothing to do with what the actual raw score you got on. So with the 63 could be maybe out of like 100, or it could be out of 1,000. It could be out of like 66. It has you really can't figure out what percent on the test in terms of accuracy Pete got. This you can't. There's no way we can figure out the percent accuracy you got on the test. But this percentile tells you what percent of the population he did better than. So let's see which would make sense. Pete scored below the median. It's not going to be below the median because if it was below the median is at the 50th percentile. So to review the median, let's say if it's a normal distribution, median would be right in the middle, and then that wouldn't matter because that would be 50%. So it's not the median. It's not A. Now let's see about B. Cross that off. Not A. He did worse than about 73% of test takers. Again, that 60 doesn't really tell you anything about its percent or percentile. It's not that. He did worse than about 73% of the test takers. So it's so that's kind of that's going to be, it's not going to be down because it's the opposite of that. Because remember, if we drew again, if it was like a normal distribution, then what we would have is that Pete's score, let's say 63. This would be to the right of an area of 0.73. So he didn't do worse, he did better than 73% of test takers. So it's not going to be C, D, the answer will be E. T, answer number 1, E. All right, let's look at the next problem. All right, here it's asking for the value of the standard deviation, and you're only given a picture. Now, this we're gonna have to assume, since they're not giving me that much information, that this is drawn, that this normal distribution is drawn perfectly. And what we're going to use in this problem is we need to identify approximately where the inflection points are. Inflection points. So ask yourself, where would the inflection points be on this curve? Now, you took calculus, you did a whole chapter of it. If you haven't, no worries. The inflection point is basically where a curve goes from downward, like going we say concave down, to concave up. So this would be the inflection point over here. But if it did it again, then another inflection point would be here. So these 2 points would be inflection points because it's going downward, concave down. Here it's going upward, and then here it's downward. Now this is not so clear, but again, since it's drawn, since you're asking this question, it must be drawn perfectly to scale. So what I would do, if you had a ruler or straight edge, try to draw as vertical a straight line as you can on the curve. So what I mean is something like, I'll probably draw a line like that, and on both sides of the curve. Try to make a straight line so it stays on as much on the curve as you can. And you can see that the center of this line, so from here to here, let me draw it in purple. No, let me draw it in red. this part to this part is concave down. And then to the right of that point, it's concave up. To the left of this point is concave up. So these will be about where the inflection points are. And what the point of finding that is that the distance that the inflection point is from the center. So draw the center to the top would be, be right about 2, it looks like. Well, let me see that. Again, usually on a test, we won't want to worry about being this accurate, but this would be the middle, right? Right, that vertical line would be right in the middle, right at 2. Middle is at 2. And so then if I want to figure out how far this value, this inflection point is from the middle, that'll be the same. This distance is supposed to be the same length or the same value of your standard deviation. So in other words, the distance from the mean to the inflection point is the value of your standard deviation. But from here to here, or from here to here, that'll be -1 standard deviation. So then we just draw a vertical line as best we can again. And it's gonna be like, should be right between, right between 4 and 6, so it's probably a 5, and over here on the left, halfway between 0 and -1, looks like it's probably supposed to be -1. So the distance from 2 to 5 and from 2 to -1, and again, they're usually gonna give you answers that are pretty clear. It means there's no decimal, so the distance from here to here is 3, from here to here is 3 as well. So your answer is gonna be D. Standard deviation is 3. That's a good one. 2.3. All right, here we got the rainwater is collected. Water collectors at 30 different sites near an industrial complex, and the amount of acidity. The pH level was measured. The mean and standard deviation of the values are 4.6 and 1.1 respectively. And the pH meter was recalibrated back to at the laboratory. It was found to be an error. Found to be an error. The error can be corrected by adding 0.1 pH units to all the values and multiplying the result by 1.2. The mean and standard deviation of the corrected pH measurements are. Okay, so this is going to be addressing the concept of linear transformations. So, depending on how your textbook, presents this, usually it'll have something where you have like y equals a plus bx. Y equals a plus bx, a linear equation, and the mean of y is equal to a plus b times the mean of x. And the standard deviation of y is equal to just b times the mean of b times the standard deviation of x. So I always recommend just using this equation by default. And then you essentially want to find, values of a and b, and values of, the mean of y, mean of x, standard deviation of y, standard deviation of x. It depends on what the problem is dealing with. This is only times. So make sense of this now in terms of these equations. So we usually, will have functions of x. We usually go from x to y. So the original values are usually in x, in terms of x, and then the transform values we use typically in terms of y. So we're going from x units to y units, from x to y. So let's look at this. It says the mean and standard deviation of the values, so the original values are 4.6 and 1.1 respectively. So we're going to say that the mean of x is 4.6, and the standard deviation of x is 1.1. Now, the equation for y, it says, because after it was found to be corrected for the error, was that you had to add 0.1 pH units to the original values and then multiply the result by 1.2. So going from X to Y, so the original values are X, so multiply them or add 0.1 to them. So we're gonna have X plus 0.1. That's what this part means. And then it says multiply them by 1.2. So what we're going to do is multiply this entire thing by 1.2. And that'll give you your value or your equation for Y. Now, essentially now we're just solving this, for Y, which is pretty much already solved, and for the mean of X, mean of Y, mean standard deviation of X, standard deviation of Y. So just doing algebra, we'll distribute that 1.2 to X. So we have 1.2X plus 1.2 times plus 1.2 times 0.1, that'll be 0.12 is equal to Y. So this is your equation for Y. And then going back to this, using this equation, that means your A is the 0.12, and then your B is the 1.2. And then using this, we want to find the mean and standard deviation of the corrected pH measurements. So we want to find the mean of Y and the standard deviation of Y. We want to find those. That's our goal. That's what this is saying. Mean standard deviation, corrected pH measurements. So what we do is to find the mean of Y, we are going to multiply the mean of X by B and then add, A. So the mean of Y would be A, or 0.12, plus 1.2 times the mean of X times 4.6. That's simple. So you can calculate it now. 0.12 plus 1.2 times 4.6, 5.64. Now, for the standard deviation of Y, all you have to do is multiply the standard deviation of X by B. The standard deviation of Y would be equal to B, or 1.2, times the standard deviation of X. Standard deviation of X is 1.1, so 1.2 times 1.1, and that'll be 1.32. And so these are your answers. So we look, and then that means our answer for 3. All right, so that's 2.4 now. Here we have another graph we gotta analyze. Well, drawn a little light and trace over it. So this figure is showing a cumulative relative frequency graph, and it shows the number of ounces of alcohol consumed versus, the percent of alcohol, versus the percent of adults that consume this much. So let me read that over the poorly read. So the number of ounces of alcohol consumed per week, so number of ounces of alcohol consumed per week measured in ounces, versus, the percent of adults So what percent of adults consume, this corresponding amount of alcohol per week? So it's asking for what percent of adults consume between 4 and 8 ounces of alcohol per week, according to this graph. So we're going to look from our X values at 4 and 8, and we're going to see what percents correspond to 4 and 8 ounces. So for that, again, we do our best to draw, vertical lines that go perpendicular. There and there. And then we find, where they intersect the cumulative relative frequency graph approximately, and we draw horizontal lines to find the corresponding percents as best we can. Okay, so this looks like it's going to be right about 20%. And here looks like about 60%. Now let's see, it's saying between 4 and 8 ounces per week. So from 20 to 40 or 20 to 60%. So 20 to 60%. So the answer is the difference in them, which is 40%. The distance from 20 to 60 is 40. So the answer will be B.